Hi, and welcome back to the channel. This week's problem is all about finding the area of this blue circle. Now, we have got a few shapes here. We have got a larger square, the outside shape. We've got a smaller square, which is touching the side lengths of that larger square, and it's at an angle, as you can see. And in between, or made up from, the inside smaller square and that larger square, where they're touching each other, are four triangles. Okay, of area 24, and as you can see, the area of that smaller square is 100. We've then got a circle which is tangent to two sides of the outside square, the larger square, and tangent to one side of that inside smaller square. Can you work out the area of that blue circle? If you want to have a go at solving this problem yourself, pause the video now. Otherwise, I'm going to show you my solution in 3, 2, 1. Okay, so the first thing that I would do here is to work out the side length of that inside square, because we've got the area. Now, that is going to have a side length of 10, because 10 times 10 is 100. What I'm then going to do, and which you should do whenever you've got a problem involving circles or sectors in any way, is put on the important radii. Okay, so I've put those on there. Now, a radius meets a tangent at 90 degrees. So I haven't put those on the diagram, but there are 90 degrees between each of those radii and those lines, those tangents there. Now, I also know that tangents to a circle that meet at a point have equal length. So I can call these lengths A, they will be the same, and I can call these lengths B, they will be the same. Now, I know, because as I say, a radius meets a tangent at 90 degrees, that this shape here is a square. And so this height is going to have a length of R, and this length here will also be R. Okay? Now, from there, what I know is that the side length of that smaller square is 10, but I can also say that it's A plus B. And so I can write this equation down. A plus B is equal to 10. Next, I want to have a look at the angles inside each of these triangles, because they look like they could be the same. So let's explore that. Let's see if they would be identical, would be congruent triangles. Now, if we consider the angle here, okay, if I was to call that something, let's say theta, this is theta, I would then do 180, take away theta, take away 90. So this angle would be 90 minus theta. Now, angles in a triangle add to 180. So to then work out this angle, I would do 180 minus the 90, the right angle, minus the 90 minus theta would give us theta again. And so those angles have to be the same. Whatever they are, they have to be the same. Now, I know that the other angle in that triangle, in either of those triangles, both those triangles has to be the same as well. And if we were using the green angle as theta, the red one would be 90 minus theta, because like we said before, angles in a triangle add to 180. So now I know those triangles have got all three angles the same, and so they must be congruent, identical triangles, okay? Congruent or identical, whichever word you prefer. Congruent's the mathematically correct one, but yeah, they are the same triangle, just different orientations. Now, that means the lengths are the same as well. Now, what that means is this shortest side of the triangle has to be the same. And so this length has to be B plus R, okay? And by the same token, the longer side that isn't the hypotenuse has to be the same. So that's going to be A plus R, okay? From there, I'm going to start considering the areas. So the total area, the area of the larger outside square. Now, I can do that by getting the side length of that larger square. So that's going to be R plus A plus B plus R squared, because that's the side length squared. Now, I can also make up the area of the larger square by doing 100, the area of this inside smaller square, plus 4 24s, because that's the area of the triangle. So let's put that as an equation, and we get this. A plus R plus B plus R squared is 100 plus 4 lots of 24. Now, if we rearrange, because it's addition, the B and the R, we get something which now, hopefully, is obvious we can substitute in for. So that A plus B is going to be 10. So I'm going to simplify the two R's to 2r, and then I'm going to substitute in for the a plus b. So I get 10 plus 2r all squared is equal to that 100 plus 4 times 24, which is actually 196. I'm then going to expand the brackets there, and I'm going to get 100 plus 40r plus 4r squared equals 196. I'm going to rearrange the quadratic so it's in the normal format with your squared term first. I'm going to subtract the 196, and then I'm going to divide everything, by 4. So that's going to give us r squared plus 10r minus 24 is equal to 0. From there, I'm going to factorize this, and you could use the quadratic formula if you wanted to. That's another valid method, or completing the square. I'm going to get r plus 12 times by r minus 2 is equal to 0, and that will give me an answer or solution of r equals negative 12 or r equals 2. Now, r obviously can't be negative 12 because r is a length, so it has to be a positive number. So that means the only solution is r equals 2. The only valid solution is r equals 2. And so therefore, the area of that blue circle and the answer to our question is 4 pi units squared. If you use the same solution or a different solution, please share it down in the comments below. I believe there's probably at least another couple of ways you could approach and solve this problem. So let me know if you found any of those in the comments below. And all that's left to say is thank you so much for watching. If you enjoyed this video, make sure to drop a like on the video. And if you're not already, please consider subscribing to the channel because it helps so much more than you know, and well, probably know anyway. Thank you for watching. I will see you next Monday, 5 p.m. for another problem solving video. Until then, bye-bye.